All right, functions class. This is a video on special right triangles, and we're going to start by figuring out how to write these. So what I would like you to do is I would like you to draw an equilateral triangle on your in your notepad with a side length of 2. Now remember, an equilateral means equal sides. So 2, 2, and 2. So go ahead and hit pause and do that. Okay, so you should have a triangle that looks something like this. Now, I have the degrees in there of 60 degrees, and I came up with 60 degrees inside that equilateral because if you take 180, which is the sum total of the interior angles, and divide it by 3, you get 60 degrees. So each angle has to be 60. So I said that we were going to try to draw a special right triangle. So we are going to turn this into a 30, 60, 90 degree triangle. And when we do that, one way to do that is to cut it right in half. So if we bisect one of those 60 degrees, and I'm going to go ahead and just choose the top, mostly because it's easy, but you could choose any one. You could go this way, you could go this way. It really doesn't matter. I just chose the one that aesthetically looked the best. So when I do that, I cut it right in half. Now, that makes this angle right here, that makes this a 90, whoops, this is 90 degrees. And when I cut 60 in half, this turns into 30. So now I have two different right triangles. But now I know what the side lengths are, right? So if I cut this one in half, exactly in half, this becomes a 1 and a 1. The last thing I have to do is figure out that final side length. So then I have two 90 degree or right triangles, sorry, not 90 degree, but two right triangles. I've got my right triangle, so this is this half of the triangle, and this is this half. So let's just look at one of them. Since they're identical, we can just look at one and apply the same principle to them. So then let's use the Pythagorean Theorem to solve for that missing length that we don't have. So when I ask you on the test to do this, if you can't remember, but you can remember to draw an equilateral and cut it in half, that's one way to do it. Another way to do it is just to remember that this triangle has some special properties that we're going to use a lot. And you'll use them going forward in trig and beyond this class. So to find this, we're going to use the Pythagorean Theorem. So we know that the hypotenuse has to be on the outside. It's going to be equaled. So 2 squared equals 1 squared plus x squared. So then we get 4 is equal to 1 plus x squared. And we're going to subtract 1 from both sides. And then we take the square root. And we end up with x is equal to the square root of 3. So now we have all of our measurements. So now what I want you to do is so just like we've been doing in class where we would say find the sine of A for this. So now what I want you to do is I want you to do it for the 60 degrees right here, this angle right here. I want you to find the sine, I want you to find the cosine, the tangent, I want you to find the secant, the cosecant, and the cotangent. So go ahead and hit pause and do that. Okay, so if we were to find the sine of 60 degrees, then we would end up with, let's see if I can get this to work. There we go. We have the opposite side over the hypotenuse. So the opposite side is the square root of 3 over the hypotenuse, which is 2. Now let's do the same thing for cosine. So the cosine is the adjacent side over the hypotenuse, so we get 1/2. And then we're going to do the tangent. So remember that if we have the opposite side over adjacent, which is the square root of 1 over 1, that's going to just be the square root of 3. All right, so now let's find the cotangent, because we know that it's just a reciprocal of tangent. So the cotangent is going to be square root of 3 over 3 when it's fully rationalized. Then we have the secant of 60 degrees, which is the hypotenuse over the adjacent, which is just 2. And then we have the cosecant, which is the hypotenuse over the opposite, which is 2 over the square root of 3, rationalized 2 root 3 over 3. So make sure you get that in your notes. This is something that I'm going to ask you to do on the test without a calculator, without notes, and without a triangle. So I want to make sure that you have this and that you can do it. So now what I want you to do is I want you to do it all for 30 degrees. So go ahead and hit pause and do 30 degrees. Okay, so if we were to find the sine of 30 degrees, remember we're looking at this angle right here, this one right here. So the side opposite is 1 and the hypotenuse is 2. So the sine of 30 is 1 over 2. Then we're going to do this one because it's the reciprocal. It's 2 over 1 or 2. Then we're going to do the cosine of 30. So the cosine of 30 is the adjacent, which is the square root of 3, over the hypotenuse, which is 2. And then we're going to go ahead and do the reciprocal of that. So we have 2 over the square root of 3, which is 2 square root 3 over 3. That is fully rationalized. Then we're going to do the tangent of 30. The tangent of 30 is the opposite over the adjacent. So the opposite over adjacent would be the 1 over the square root of 3 or the square root of 3 over 3, fully rationalized. And this is going to be the reciprocal, which is going to be the square root of 3 over 1 or the square root of 3. So this is something I'm going to ask you to do. This is something that's going to be expected of you, and you will need to do this. So go ahead and make sure you get this in your notes. Now we're going to do a different triangle, another special. So what I want you to do is I want you to draw a square with a side length of 1. So if we are looking at this, we know that this is a right angle. We know that this is a right angle. We know that this is a right angle. So if we wanted one of them to be 45, like we did with the equilateral triangle, we could cut one of these in half, right? So if we cut one of those in half, then we end up with 45 degrees here, 45 degrees here, a side length of 1, and a side length of 1. So go ahead and get this in your notes, and we're going to talk a little bit. So we have that. So we have a 45, 45. We have an isosceles triangle, meaning that I have two angles that are congruent, and I have two sides that are congruent. And that's something very easy to remember. And so we need to figure out what this side length r is. So we're going to use the Pythagorean Theorem again. So we're going to get 1 squared plus 1 squared equals r squared, which is 2. So then we end up with that r is equal to the square root of 2. So now we have our 45, 45, 90 degree triangle. So now we need to do the 6 trigonometric, if we do the 6 trigonometric functions for this, we're going to do the same thing. So we're going to find the sine, and the sine is the opposite over the hypotenuse, which is 1 over the square root of 2, or fully rationalize the square root of 2 over 2. We're going to do the cosine, which is the adjacent over the hypotenuse, which is 1 over the square root of 2, which is the square root of 2 over 2. And then we're going to do the same thing for tangent. We get 1 over 1 or 1. Then we're going to find the cotangent. Again, we get 1, because the reciprocal of 1 over 1 is 1 over 1, which is 1. The reciprocal for the cosine, which is secant, would be the hypotenuse over adjacent, which is the square root of 2 over 1, which is just the square root of 2. And if you go back and look at sine, we ended up with the square root of 1 over the square root of 2 again. So we're going to flip that and end up with the square root of 2 over 1, or the square root of 2. So this one you need to also know. What's great about this is it doesn't matter which one you look at. They're both 45 degrees. They both have an adjacent side that's 1, and they both have an opposite side that's 1, and the hypotenuse that's the radical 2. So that's what's really great about these, and these are special triangles, and we know a lot of things about them, and we can learn a lot of things. So these are things that you're going to need to know. So make sure this is something you can do without notes or anything. So here's a table, and if you want to go ahead and get this in your notes, you can. So yeah, thank you so much, and yeah, make sure you can do this. So see if you can do this warm-up. This is what we started class with the next day after we learned this lesson, so make sure you can do it.